What's up, guys? So Destin from Smarter Every Day released a video about his new barbecue scrubber. I recommend checking it out and watching it. But there were a lot of points brought up into it that were really interesting and really hit home for me, to where I wanted to go through the video and add some more color, because Destin has the requirement of a 45-minute video and I don't. So I wanted to dive into it. And this video is going up over on the Tangled channel because Tangled has this sort of motif about it, and we really didn't know where else to go with it. For anyone who's new and is here for the first time, my name's Gabe. I run a 3D printing company based inside the States, and we manufacture a 3D printer filament, which is also made in the States completely, and we've made it cheaper than even overseas stuff. So that's my kind of background and resume. I've also been part of the design and manufacture of about 200 products over my career. So in this video, I want to break down what Destin's talking about, some of the problems that he had, maybe give him some ideas. I don't know, but I highly doubt that. Destin's a pretty sharp dude. But from there, hopefully just add some more color to the conversation. So let's just dive right in.
Is it possible to make something in America and be competitive in the marketplace?
Yes. Yes, you can.
This video documents an experiment that lasted over 4 years. The goal was simple: to manufacture a product here in America. The challenge is that almost every single market force pushes manufacturing to make things overseas. What happens if you ignore those pressures and you just make something here anyways? This channel is supported by the Patreon.
So one thing I kind of want to highlight is that Destin did this project over 4 years. That's how long it takes to develop a project, to understand the product, to test it, to iterate on it. Generally, 4 years is a little bit long, but Destin has a full-time job. But when a lot of inventors make the mistake when creating a product that it will happen in days, weeks, months, and it doesn't. Setting up a supply chain and verifying stuff and getting it ready to go so you can actually make thousands of them takes a while to get rolling. Destin had the additional kind of constraint of working inside the United States, where it could have happened if he had gone immediately to overseas, but he'll get into that probably.
Patrons of Smarter Every Day, their financial contributions, economic forces that have shaped the world since World War II are changing. And I believe people in your community who understand how to manufacture things are going to be even more critical in the coming years. My home is here in America, but this video's lessons doesn't just apply to America, it's wherever you live. If you can manufacture things locally, then that ensures your self-reliance, your stability, and ultimately, your freedom.
This is a really good point. Manufacturing is so fundamental in order to have stuff that, of course, being able to do it yourself wildly improves the self-reliance of your nation, your community, and that kind of thing.
Let's explore this topic.
Get ready for summer projects and serious savings during D&B Supply's DeWalt sale.
And go get smarter every day. I started this process with the goal of making everything you see here in America. All of these components go together to make one thing, and that thing is a grill scrubber. This is called the Smarter Scrubber, and we'll talk more about that later, but for now, I want to tell you how we're going to lay this video out. There's 3 parts to this video. The first part is why I wanted to do it. Like, why did I want to perform this experiment? Secondly, how those components. And finally, I want to pitch you on buying that product. I want you to buy it, not because you're watching some YouTube video, but is it actually competitive in the market? Is this a thing that can exist on its own in the marketplace?
So I want to pause right there on those prices of those things. The most expensive scrubber I can see on there is 19 bucks.
I'm going to give you that pitch. And
right there is one for 25. There's a set on the right for 40.
We'll see. Part 1, why? Both my mom and my dad were union auto workers. United Auto Workers 2195 here locally in North Alabama. They made steering components for vehicles. My mom worked on the assembly line. My dad was in tool and gauge. When they would come home, they would smell like cutting fluid. And that smelled like work to me. It smelled like productivity. They made things. And everybody that I knew, their parents made things. Middle class America. The American dream was alive and well. And then things changed. With NAFTA and CAFTA, it wasn't one political party, it was everybody. Globally, things were changing.
This is really important to point out. like, yes, no political party is to blame for any part of this stuff. It is everybody. It is general legislation and the globalization that comes along with it. Very well intentioned at the time with core goals, but it's not a political issue.
So that it made more sense economically to move manufacturing facilities out of the United States, and that's exactly what happened. This is more than Destin is upset because NAFTA took mommy and daddy's job. I don't even know that NAFTA did take mommy and daddy's job. I think things were changing before that. So the global economy is so complicated, I could make a whole channel on it, but what I want to do is just take 60 seconds to demonstrate that I understand this is a complex topic, and I just want to throw some ideas out there and let you think about it, and then we're going to move on with this video. But it's just a really interesting thing to think about. Okay, so a long time ago, things were better, right? That's called golden age thinking. Every civilization has done that.
No, it's never been better. 10 years ago was worse than right now, and 150 years ago was way worse. 150 years ago, half your kids died when they were born, and you had an ox cart to get around. Now is so much better in every single way. And I am perfectly happy to take Destin's thing and run with this a little bit, because people do make this mistake of whining about the current situation. And the current situation, no matter how bad you may imagine it to be, is not nearly as bad as it used to be. And that is an incredibly humbling realization that makes you appreciate the situation that we're in right now. And enjoy and be okay with it. Not okay with it, but not stressed out about it.
To return to the way that things were, things would be better. That's a powerful, nostalgic thing, but it's not really accurate. Because if you think about it, we went from this type of shipping to this type of shipping in 150 years. And that is analogous to the complexities of global trade, because wars were fought when we were using wooden boats. Imagine how complex the economics are when you go to boats like this with containerized shipping. In World War II, the Bretton Woods Accords in New Hampshire, America decided they were going to guarantee the shipping lanes would be open so global trade and global prosperity could happen. We started doing that. Everybody started doing good things. And then people started exploiting cheap labor in developing nations, and then profit became king. And so now we have billionaires and we have a wage gap, and it's very complicated. And so people are pushing factories overseas, and it's good for local communities overseas, but sometimes it's not. Okay, so that was impossible.
Yes, Destin, give it a good old college try. Yeah, it's a big thing to cover in 1 minute or so. And I don't have much to add to him, except that, yes, we made it open to globalization. Therefore, you have an entire flat planet to where every labor sources are moved to wherever stuff needs to go. And general structures in a hometown economics and that kind of stuff start to push it in that direction. I can't add any more than what he had in a YouTubeable format.
I didn't even mention unions, collective bargaining agreements, all that stuff. It's a very complicated issue. And I'm not like, America is dominant and must be. No, that's not what I care about. I care about people. I love people. And I think these issues are more than something that can be distilled down to like a one-line zinger that you can use to dunk on people who differ with your views politically. This is complicated, and we as people have to solve it because we're not agrarian anymore. We have industrialization that can make food, so we must produce things as people, not just in America, everywhere. I just don't want people to be exploited in the process. My answer to all of this is Jesus, the golden rule. Do unto others as you would have them do unto you. But we have to figure this out. Let's move on with the video. I remember this period of time not understanding how important these global shifts, literally, were changing the town around me. I become an engineer. I learned how to draft and draw parts that hopefully would be manufactured sometime in America. But then when I got out of school, there were not many plants to go work at. Fast forward a lot of stuff, and then you'll get to the 2020 global pandemic. The 2020 pandemic made a lot of...
One thing real quick, around places to go work as an engineer, designing parts and pieces. It is rougher. Right now, all the software developers get all the credit, but like the mechanical engineering and aerospace and civil and all the rest of them, there's not a super high demand for them right now because a lot of it is overseas. Those jobs are still very much in demand, but you have to move. They may not be in their local area. Like in our hometown, Boise, Idaho here, every single other business owner who is dealing with manufacturing completely fights with the challenge of just finding somebody who can do CAD reliably and also show up to work on time. This is to do CAD design and that kind of stuff does not require an engineering degree. It literally requires about 2 to 3 months of just training, and you are very proficient and very useful at it. But then you have to be a reliable human. And I don't want to get into the whole just generation or whatever else it was. That's not what it is. It is training and kind of expectations of people have shifted to where it's tougher to hire people. But there's also a problem with how management pursues hiring people and giving them value for the work that they're doing there.
People mad for a lot of reasons. It made me mad. I don't get mad very often, but it did make me mad because of manufacturing capacity in America. So when everything went down, everybody wanted N95 masks and face shields, and they couldn't get it. When the president starts talking about airplane shipments from China, because that's the only place we could get these N95 masks, I realized this is a big deal. We can't make the things we need. And I'm not talking about the mask debate.
Here's why this is a big deal, because airplanes are the worst way of transporting large amounts of goods. A boat, a ship, a carrier ship filled with N95 masks, I think carries probably about 10 to 100,000 times more. No, I think it's almost solidly 100,000 times more than what an airplane can carry. Like literally an airplane carries like one single shipping container, and a shipping container ship carries about 100,000 10,000 shipping containers. Depends on the ship. Some of them are really big, and quite frankly, when I say 100,000, I feel like I'm overestimating that. But it's also been a moment, and I'm also feel like no, I'm not, because I remember it being absurd. But the amount of cargo that could be moved with a plane is so small that if you were resorting to that, there's literally nothing available.
Like, imagine, if we're talking about individual airplanes coming from China, do you think Alabama is on the priority list of where those things get distributed? No, we weren't. And so as a local community, we decided we're going to 3D print masks for our medical workers, the N95 masks, the face shields and stuff like that. A guy in California had developed a system to do this safely, so we did. We came together. It was a really good community moment. We 3D printed these things, but we realized very quickly this is slow and very difficult. We need to...
No, 3D printing can do it just fine at volume. And all the 3D printing nerds down there whining about how masks do or do not work, be quiet. No, they were fine. During COVID myself, I was on, I had joined up with a number of organizations and like R&D teams to help in design of some of these things and the preparation for it. When Italy was going up, we were working on it. And it became very clear to me that, again, it came down to like the scale of it all. 3D printing could produce at volume, but it was not nearly enough volume. You're talking about millions of pieces in a few days, in a matter of days, in a couple of weeks, and 3D printing doesn't operate on that time scale. It can make millions of parts, but it can't do it in that time scale. The scale, the 3D printing community and these types of things are fine for the smaller communities, but they also don't work at the city level. This is tragic, but I know for a fact that probably about 70 to 80% of donated 3D printing supplies that were donated to hospitals and that kind of stuff were immediately thrown out because of sterilization, bad quality, yada, yada, because there just was not process control around it. But COVID exposed all this stuff.
To be able to manufacture things. And so I started trying to find where I could manufacture these things, and this revealed to me how anemic our manufacturing capacity in America has become, because I was waiting on some billionaire to come save us, and it didn't happen. You know what happened? I went and found a guy.
This is a good small comment around that on billionaires. No, you shouldn't wait for billionaires to save you. It is important for organizations, communities, and countries to be wholly independent. Billionaires are not some version of government that is supposed to swoop in and save you. Quite frankly, it is very, very useful in life to ignore the existence of billionaires, because despite what the political conversation is, what they do really does not affect you very much in your day-to-day life. So, yeah.
here locally in Alabama. His name is Chris Robeson. He knew how to make an injection mold, and he did. We worked together and we created an injection mold here in Alabama. This is the model number Huntsville 02 Made in Alabama face shield. This is what was distributed here in Alabama to our medical workers. You put a little piece of plastic over there, and we used this in hospitals all over the state and even in adjacent states. So this whole pandemic made me realize that our manufacturing capacity in America has been gutted. If Chris had decided to retire before I needed that mold made, we would not have been able to make an injection mold in my area, and this made me mad.
This is a very stark truth. All of this expertise is in the form of expertise. Very little of it is written down, and the nuance of design for manufacturing, like making molds, is an art. It's not necessarily a science. There is not a checklist of things to go through. It is really about and that art and that science and that trade is dying out as people die because it's not being transferred, because it literally takes years to learn this stuff and understand the context and the nuance of it. And yeah. Yes.
I realized the knowledge chain almost broke, so I made this tweet asking about how I would find local manufacturers in order to make things in America. That's what I realized had to happen, and so I started on the journey. All right, I'm going to pause here and introduce you to the last, probably most important.
One thing I want to say about this has gotten phenomenally easier now with AI. Searching for a local manufacturer or manufacturers in general used to be very, 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 very difficult, because there were either too many or too few or just a bunch of Chinese results and ads and that kind of stuff. But with the advent of AI search like ChatGPT Deep Research, you can just say, hey, ChatGPT, give me a list of 10 manufacturers in the state of Alabama that are capable of doing injection molding. Give me their estimated price range and give me their phone number so that I call them. If they don't have a phone number, I don't want to talk to them. And you can find them fairly readily or get a start on it. You can say, I'm looking for local shops, single person teams, those kind of things. And all of that goes into it. Whereas that wasn't really feasible a while ago. So even though there are a lot fewer manufacturers, AI has been incredibly useful in surfacing them and making them findable as people learn to use it.
Important person of the story that you need to know about before we get going, John Youngblood. John owns a small business.
I know a guy named John Youngblood. I grew up with a guy named John Youngblood.
But John had a very clever idea to solve these problems with chainmail. Now, I got excited about his idea, and I wanted to get involved as an engineer and just help him in general, so we decided to work together. I tagged along as John presented his idea at a roundtable discussion of local business owners.
The problem is that every product out there that's a grill scraper is mediocre at best. I know I'm buying a disposable product.
At Avis, our only plan is to make sure you keep yours. And for a limited time, save 20% when you pay now. Visit avis.com/plan-on-us for details.
They don't believe how toxic this is. If you're still using a plastic or wooden cutting board, you need to hear.
Maybe one a season.
John got a...
So this is this group I want to really highlight because those were appear to be actual business operators who are in there giving advice to folks pitching their ideas. And that is quite rare and terribly, terribly useful for getting these products off the ground. The reason they're quite rare is because for the business operators in the room, it's very often a big waste of time because everybody has some widget and they're not going to chase it down even with the advice from the group there. So those organizations are fantastic. They're super big time sinks for the people who volunteer to help out with them.
Start by making wooden grill tables right here in the USA, but he's also worked with people overseas to make other grill accessories. John was experiencing pain because of that. I don't know if you realize this, but as a small business, if you have an idea and you get it made overseas, that's cool, but they have all the tooling to make the thing that you wanted made. So at night, they can literally just crank up the machine, make more of them with less high quality products, and they can just counter sell against you on Amazon and you have no recourse. There's nothing you could do. This is one of John's best-selling products on Amazon. At least it used to be, because look at all of these knockoffs. They're everywhere. The interesting thing about this is John has a patent, and he's tried to get these other things taken down off of Amazon, but he's found it almost impossible to get Amazon to respond in a timely manner. It's like playing whack-a-mole. Look at all these letters he had to get lawyers to write. That's a lot of money. The interesting thing is, Amazon almost tells these manufacturers overseas what to knock off. If you go to the product page, you can see how many were sold in the last month, and all they have to do is say, oh look, that one sells 3,000.
Yes. Yes. I've used that strategy before in development of products. You go through Amazon and you look at what has the most reviews, what has the most sales recently. And there are softwares that will go and scrape that for you and just give you a ranking of products. And then you can either source that product and resell it or manufacture a new version of it. As far as the manufacturers ripping off the model, I want to be really clear about this. Those manufacturers will only rip you off after you have successfully sold a bunch of them. Many inventors make the mistake of believing that when they're in the design and tooling stage, that people will steal their idea then. That's not when it happens. It happens after you're in production and after it's being made. So don't try to protect your idea while you're developing it. But you have to be ready to protect your idea once it's out in the market and rolling. Because you're right, patents are only enforced if you enforce them. They are not a magic document. You have to have lawyers go after these companies and get them. But the patents have to be international, including China and the US. So you have to file a patent there, file a patent here, and then you have to do a claim over there, go through the system. It's a hugely bureaucratic mess that was not built for the scale of innovation that exists in the world today. My advice to most people creating products in this scenario is that you have to be ready to evolve and compete. The product itself is only one facet of the business. You have to learn to market, learn to advertise. Price is not, if you are priced fairly, the difference between $5 or $10 doesn't matter. A consumer will purchase the first one they see that convincingly solves their problem. So price is not the main spot to focus on. All the other factors are important. And in fact, Destin in this video goes through it when he's comparing the grill scraper. Like there's other features that are important and you need to highlight those. And build quality is not necessarily the right one, but it's something to be aware of. But yes, this is absolutely a problem. Amazon as a marketplace doesn't have to deal with it because it's technically those individual companies competing with you, not Amazon. You can make arguments about what their domain of responsibility is, but ultimately it's the same as if you started up a store right here and then somebody started up a duplicate store right next to you, but cut the price by half. Is that unfair? Does that suck? Yes, but you're in a competitive landscape and you're in a globally competitive landscape. With the Chinese goods, the huge advantage that US manufacturers have is that you did not have to ship it across 2,000 miles of ocean. And that can be a tremendous advantage.
Units a month, that's clearly what I want to pirate. So these product pirates go and they'll take a really good product like his grill torch and they'll just knock it off. And parts of it are exactly the same. Other parts of it are a little different because they want to make it cheaper. Like for example, on John's unit, there is a removable screw that allows you to take the tube off in the event that a dirt dauber gets in there or something. Not on the other unit. There's nothing like that. It's glued in position. You just have to throw it away. It's weird.
This is an interesting conversation about design. I would say that the one without the screw is better, kind of from a fundamental standpoint, even though it's not as repairable. But it is more reliable and it's more affordable to manufacture, which means it can be sold more often. And this is kind of a conflict between engineers and consumers. Consumers prefer disposable stuff because that is what the market says. Engineers prefer making something that will last for 20 years. But that's also how you go out of business and become anti-competitive. If you make this perfect modifiable thing, number one, you're overrating how much work people will do to fix it. I'll turn on the grill torch and I'll be like, it's plugged, it won't turn on, the lighter's broke or something. I won't assume that some bug crawled in there and dropped its nest that's plugging it up. Then I need to disassemble it and clear out the nozzle. Call me cynical, but most consumers are not interested in that level of self-reliance.
because they're selling this for half the price, but at the same time, they're taking all the business and they're making lower quality products. Not only does this mean counterfeit goods for buyers, look at what sellers are saying in Amazon's own seller forum. Amazon's inability to police this, or at worst, unwillingness to prioritize it, that's destroying small businesses and manufacturers in America who depend on the very idea of intellectual property to protect them from fraud. So this is one of the main reasons why John wanted to work with me. I wanted to work with him because I wanted to make something. And
for small businesses out here, this is one of the excuses to use an independent website. But with an independent website, you lose all the traffic and credibility that Amazon gives you. Being a seller on Amazon makes you more legitimate because it's hard to get on Amazon, quite frankly, right now. So there is a necessity for business operators to be clever in how you operate in order to do it well, how to market differently, how to present your stuff differently. The thing I would say, again, with those listings, and I don't want to bash on this, but like all of them had the exact same product photo. White thing, white background thing, turned sideways. You have to follow Amazon standards, but there's plenty of ways to be creative with that so that yours pops.
he knows the business side, but he wanted to work with me so we could use the YouTube channel to tell people about the product and not have to sell it on Amazon. So again, Amazon.
Huge advantage. YouTube channels are free customer acquisition, comparatively, rather than buying ads. So it is a good thing that Destin's available to this. This video has 2.5 million views. They have sold a few of these scrubbers, and they have reached the people who are interested in them and that kind of thing, and brought up this topic. So YouTubers, like I was saying, a product is multiple facets. Very often US-made products are made more expensively, and then you also have to pay for ads on top of that. If you can make it more expensively, but then also reduce the cost of your ads, you can get back to price parity with the cheaply manufactured ones that have to pay for a lot of ads in order to get them sold.
Do unto others as you would have them do unto you. Let's get to part 2 of the video. How did we build this thing? To understand why we have all these parts, let's think about the problem we're trying to solve. We have grill grates, and we're trying to scrub it with chainmail, right? So in order to do that, we need the chainmail to kind of be compliant around those bars. So we want to apply downward pressure. To do that, we need something squishy behind the chainmail that when we push it down, it wraps those chainmail links around those grates. So I figured out that in order to attach the chainmail and the rubbery part to a handle, we were going to have a problem because the squishy part would break. So what we need is some type of adapter that could go between the squishy and the rigid handle, and then that way you could move the whole thing and it would all work.
What a fantastic product demonstration, prototype, minimum viable product right there. Do that. Put stuff together with cardboard when you're building a product. Show it off.
As one. So that's how we did all this, and I learned from the pandemic that the key to making things fast is injection molding. I covered injection molding in the MVP disc golf disc video. You have 2 parts of a metal mold and you clamp them together so that they have a cavity in the center, the shape of the part you want. You then inject molten plastic into that void and let it solidify, and then you open the mold and you kick out the part. That's injection molding. So I started the design process, and for an engineer, you just start in CAD and you start drawing stuff. So I started making things and started figuring out how to get a rubbery backing, and I ended up with a really nice history of all the designs right here. So it's kind of fun to look at. I knew that I had to design it so that it could be molded and made and then ultimately assembled. I'm a little embarrassed showing you all this stuff. And some of the earlier designs, I had like these little posts because I had to hold the chainmail around the rubber. My thought was to hold the chainmail with these posts, but the posts started breaking off. So I was making more problems than I was solving in the early days. But pretty quickly, I figured out that I was going to need multiple components. I needed something on bottom that I would adapt the squishy to. I also needed a top cover, and I needed to be able to assemble those. Now, mechanical engineers know from reading books by Toyota folks that it's better to click things together than bolt them together if you can. It makes the manufacturing process fast. So
let me harp on this just a little bit. Screws are the devil. Yes. Fewer parts and pieces make stuff stick together permanently. Again, from a manufacturing standpoint, if it clicks together, it doesn't come apart. Whereas if you screw it together, the screws go loose. And the screws are also stupidly expensive to assemble and purchase compared to a click mechanism.
parts, and I have a slot, and I could put them together like this, and I could push them, and they just click together, then that would be my assembly process. And so these posts ultimately were foolish. And so I ended up with something that looked like this. So I had a rubbery component that I molded with a 3D printed mold that I made. I really enjoyed that process, but ultimately it's too complicated for making the squishy component of this. I did finalize the rigid components. I had the cover, I had the adapter, and they clicked together. After I finished kind of the design, I had the adapter and they clicked together.
I didn't see how he retained the chain.
After I finished kind of the design, I decided I wanted to be able to take this scrubber head off and hold it with my hand. And so I measured my fingers and I put these little grooves on there so I could hold it and really get in and scrub really hard. At this point, I got serious about the squishy part. I knew that overmolding took too long, so I moved away from that geometry so things could like pour through there, and I went to a pad design. So if this was my adapter, I said, you know, what if I had a little pad that goes underneath that was just compliant, and the chainmail itself would keep it in place. So I started designing these little rigid pads, and then my 3D printer, which is a Formlabs Form 3, I had different materials. One was called elastic. So I started printing squishy geometries in an attempt to try to figure out what would work best on the grill. So I even tried some linear designs, I tried some hex patterns, and I ended up with something roughly like this. I had all the components, and John took it all to the hardware store and put it together with a wire, and this was our very...
So they're tying off that chain. Ugh, that's tough to assemble. If that's where they land, that's really tough to assemble. And Dustin knows this, but it is really reliable, and it's an affordable individual part count. But threading that chain is tough. Ooh.
Very first prototype. And at this point, we could only get chainmail out of China, so John started testing the different types, and he came up with some very interesting information.
When you go against the grain, it'll catch. It puts a lot of tension on the individual rings, and they're coming apart, and we're losing some.
So the way this chainmail is made is that these rings are basically closed around. They're not continuous, and as you scrape it, they pull apart because they're basically just wire rings that are not sealed. And that'll create a lot of stress on them.
So but that's a good thing. This is a good thing because we haven't ordered thousands of these pieces of chainmail yet, and we can get a welded version. It's going to cost us a little more money, but we can get a welded version that is going to be stronger, and it's going to make our product better.
The supply chain for chain is a big deal to me right now. So John's test revealed that we could not use the most common thing that's on the market, which is this type of chainmail with a radial pattern with a central ring in the middle. We found that that doesn't adapt well to the grate. So we want this rectangular pattern, and John did a lot of testing, and he arrived at not a square like this, but if we got an octagonal pattern of the rectangular grid, this will do what we need. It's really fun to play with, by the way. So this is what we need, and we could only find it in China. That goes against the thesis statement for what we're trying to do. So we worked, and we eventually found a supplier in the US that can make it. However, they can't make the quantities that we need for a price that makes sense. So what we did is we created a contract where we could buy all that we could afford at the rate they have, and we're getting about 2,000 units a month of this stuff right here.
So Destin's run into a scale problem. 2,000 units per month. They're wanting kind of the lower volume. The company probably said, if you make 10,000 units a month, then maybe we can get closer to whatever else it was. And Destin's like, we're probably not going to sell that many, or don't want to sell that many. Then they're like, okay, well then down here at this lower volume, you're going to have to pay for this much. Well, that's too expensive. And this is the challenge. Many US manufacturers can build up the tooling and automation and that kind of stuff to produce goods at scale and affordably. But the startup of all of that and the ongoing operation of it, they can't do it for a single indie product. They're like 100,000 pieces. And then we can talk about getting it set up because we can build up a line for it. But if it's this custom kind of bespoke project, which is like sub 10,000, it's very expensive.
And it's incredibly expensive. It is so expensive that is by far the most expensive part of the whole thing. But
I'll bet it costs them probably somewhere between $5 and $10 for that chain.
realize these quantities that we're able to get aren't enough. And so we have supplemented that with an Indian supplier. We said, hey, we don't want to do this in China, but we contacted our Indian supplier. We said, we need a stash of chainmail that is the quantities we need in the event that we sell any kind of numbers.
Well, the reason for this is they have a baseline that's US made, but they're like, if we scale up, we need to be able to scale up, and the US guys aren't going to be able to do it. So we need to be able to get some more chain quickly and reliably, so they're going to India.
Of the scrubbers. So we ended up buying some Indian chainmail that would augment the quantities that we could get from the American supplier, because that's all they could produce, and that's where we're at. So yeah, that's where we're at on chainmail. 1 inch long stainless steel quarter 20 bolt. This was so difficult. I know it sounds like an industrial commodity, seems like a simple thing.
The industrial commodities are the toughest part because they are completely outsourced, and they were the very first thing to be outsourced. The way the supply chain's outsourced is that you do the lowest grade kind of products or the simplest products, like here's a nut, here's a screw, here's a bolt, here's a pad, and then let them make that stuff because it's the same thing, very simple, over and over and over again. And then as those manufacturers got better, they could do more and more specialty stuff, so more manufacturing followed. But these are the very first things that went overseas.
But if you want to buy this made in the USA and you stipulate that, that changes everything. Foreign bolt like this, 9 cents a piece. In the US, average 38 cents a piece. Like here's a quote right here. If I buy 10,000 of these, 42 cents a piece. That's pretty standard. Most machine shops I talked to directly, they said, yeah, we can't even get the material for the price of the finished bolts that you're getting from a foreign supplier. Finding people to get quotes for you, very difficult. I emailed a lot of people. I sent out this tweet, it helped, and it's a very fascinating thing. Eventually, after literally months of emailing people back and forth, John picked a supplier that got them for 35.5 cents a piece, which we then verified were made in Massachusetts. So instead of a dime to get our bolts from a foreign supplier, we're doing roughly this, because we think it's important to
4 times the cost. Yep. Unfortunately, that's about right. Yeah. This is not something that's done inside the States. The bolt manufacturer that they used probably generally makes like custom fasteners and stuff for like an aerospace part or something, just really high end. And this is kind of beneath them to where it's not something that they would make on the regular.
to have manufacturing capacity for stainless steel bolts in Massachusetts, which is weird because my uncle used to work down the road at a bolt factory that closed. But now I'm going to Massachusetts to get this bolt, which is interesting, right?
Destin's not that old. This is how fast it's happened. Basically, all of the offshoring and that kind of stuff started happening significantly in 80s, 90s onward. And first kind of got the impetus in the 70s.
Very interesting. After we bought our bolts, quote came in for 19 cents a piece. Other salesmen told me there's no way that's American. I couldn't verify it. It got sketchy. I don't know. I have no idea what to do with that. I thought it would be simpler. Like, they're on the shelf. They're made in the USA. Buy them. They're this price.
With the bolt, that's the middle ground pricing. Probably is resold, though at the same time, American manufacturing in certain contexts, especially around commodities, is stupidly inefficient. And it does not take much to do it correctly, though the qualification of it and the proof that it was made in the US is something that should be readily demonstrable, especially since Destin, I don't believe, is going through any of like the typical certification standards. He's emailing people and say, hey, can you just show me that you bought this from the right people? So it's easy to verify.
Very difficult. The next part of this story is very interesting. I had my parts and it was time to injection mold. And I went to a facility that does injection molding. And I said, can you make these parts? And they said, yes, we can make the parts. And I said, that's great. I would also like to make the molds here because I want to learn more about molds. And they said, oh no, we don't make molds here. And I said, why not? They said, we don't do that. We ship the part, the CAD file to China, and they make the mold and they send it back and then we injection mold. I said, no, that's not what I want to do. I don't want my intellectual property in China. I want to make it here. And they said, good luck. And this is the moment where this whole experiment came into focus for me. I realized at that moment, we're screwed. I think we're screwed as a nation if we can't do the intelligent work of tool and die, making the tools that make the things. It used to be that America did the smart thing, and then we would send the machine that we made to another country, and the country would operate the machine in the developing world. We have flipped it. We are now to the point where the smart stuff is done somewhere else, and they send us the machines, and we push the buttons to operate the machines.
It's worse than that. We're not even pushing the buttons right now. Very few of the machines come back over here. But yes, as you send over the commodity, they start making them, they get a little bit better, and then they start to get expertise about how it is made, and then they start to do the engineering of how to make it. So they're just going from the bottom of the stack upwards. No part of that stack is coming back. We're getting parts. We're not even getting the machines. Right now, inside of tariffs, one of the things that makes me most angry about tariffs is the fact that they apply blanket across goods from China. If I, as a manufacturer, want to purchase a machine that I can push a button on to make stuff and have it shipped over here, I have to pay the exact same tariff rate on that machine as I would have to pay if I was making the parts from that machine. So why would I also import the machine and then get the parts? I would rather put that machine in some other country and import the parts, especially if I'm doing low run kind of stuff. So it's even worse than what Destin is saying here, because we're not even doing the operation of it. Many people think about the factory jobs as like the low grade stuff of like putting in screws, but tool and die and the engineering and the design of the building of the machines to make the parts is also gone and going. And it is so much more difficult to get back.
I need you to understand this, because I realize we have lost something very, very important. And we did it by lulling ourselves to sleep, by pushing money around and doing the intellectual property work, but not doing the manufacturing work. I think it was best put simply by the CEO of Apple, Tim Cook, while sitting in China when he was asked a question about tooling.
There's a confusion about China that, and let me at least give you my opinion. The popular conception is that companies come to China because of low labor cost. I'm not sure what part of China they go to, but the truth is China stopped being the low labor cost country many years ago. And that is not the reason to come to China from a supply point of view. The reason is because of the skill and the type of skill it is. Like the products we do require really advanced tooling. And the precision that you have to have in tooling and working with the materials that we do are state of the art. And the tooling skill is very deep here. You know, in the US, you could have a meeting of tooling engineers and I'm not sure we could fill the room. In China, you could fill multiple football fields.
So Tim Cook's.
This video was made 7 years ago, 2017. At that time, that was the situation. We're 7 years on. It's even worse now. The common perception is that China is cheap. It's not. If you are paying for the manufacturing of stuff, you're paying about $8 to $10 per hour for labor, which is not that cheap. Quite frankly, in the American South and that kind of stuff, there are places where like salaries are somewhere between $10 and $12 an hour for like factory labor. But China knows how to make stuff. So you go there because a factory is not a static item. You don't set up a bolt factory and then it just makes bolts. You have to know how to operate the machine, how to tweak the machine, adjust the temperatures because it's a cold day. Like the amount of tuning and operation requirements for running a factory are far more extreme than what the average person realizes. It's a very living sort of an organism and requires deep expertise about how stuff works. Injection molding sounds simple. Oh, shoot stuff into a mold. It's not. It's really not. 3D printing, also not simple. To do these things at scale, at the scale necessary for manufacturing, is a deep bit of expertise and nuance again. And China, number one, has 4 to 5 times more people than the United States does. And excuse me. And they are deeply focused on STEM and engineering in a way that the United States hasn't really been for the last few decades. The United States has been focused on coding and that kind of thing, and we got so good at it that we're replacing those folks. But manufacturing got left behind. And by the way, this is I want to emphasize again, there is a difference between manufacturer like line worker, blue collar work, and like tool and die engineer, blue collar work, or machinist, blue collar work. Those are different things, and both of them are terribly honorable. But people are like, oh, I could be a software developer or I could be a machinist, and I don't want to be a machinist because it's beneath me or something. Screw you, first of all. But number two, it's not. The amount of skill and technical expertise to be a machinist is equivalent to being a code slinger.
Said that in 2017 at the Fortune Global Forum. Now, there's 2 ways of looking at this. One way is, well, Tim Cook is of course going to say that. He's incentivized because his business is tied up in China. He's not going to cross the Communist Party because he needs his stuff to be made there. The other way to look at it is, well, maybe that's right. Maybe
the question of like the evil CEO wanting to justify their stuff. Tim Cook's pretty rich, and Apple can get their stuff made fine. And they have quite a bit of clout in China in that they've been investing $50 billion a year over there. I'm sure he can give China a compliment about their tooling expertise, or even make a suggestion about their tooling expertise if it wasn't there. If it was close, he would toe the party line maybe, but it's not close. He has no incentive to lie about it.
the tooling and advancement is, somewhere
also,
way
by the way,
beyond
it
what
was 2017, so he was almost disincentivized to lie about it because this was the first Trump round, to where it really was not helpful for him to say that China was good at stuff.
Americans can do. So here's what I want to do. I know a man that is specifically unique in the world that can answer this question. He's a friend of mine named Jeremy Fielding. He has a YouTube channel. He's an engineer. He speaks Chinese. He spent a significant amount of time exploring these topics in China, and he's right there beside you. Let's just ask him.
Meet Cinch's Customer Communications Cloud. Cinch.
Ants ignoring your traps? You need Combat 2-in-1.
All right, Jeremy. What do you think about what Tim Cook said about labor and about the tooling industry in China?
Well, it'd be hard for me to comment on tooling specifically, but I do think that we do have a common misconception, including myself before I went, that in China that their product is inferior. I mean, the quality of manufacturing is surprisingly good. And when I started comparing that mentally to all the places I've visited, because I've been to many shops here and over there, if it wasn't for the fact that they were speaking a different language, I would feel like I was in the same place. I was really impressed, and I think I would say it's at least equivalent to what we can make here. And in some cases, things that used to be available in America aren't available anymore. It's like you have to go to China to get it because we just don't do it here anymore.
Oh, that's scary. Okay, this is a tangent we could talk about for hours just on this topic. I just want to encourage you to go watch Jeremy's channel because it's awesome.
Yes, the factories over there are as good, if not better. There's a few factories still that are like on a dirt floor or something. That's what people imagine about it. But again, China has not been a low quality source of parts for a long time. Even with earlier with the barbecue smoker, or the lighter torch, it wasn't really an inferior build quality from what I could see visually. It might be made of lighter materials and that kind of stuff in order to cut costs, but the manufacturing of it was cleaner so that it could be made more affordably. So it's that. Yeah, China doesn't do a bad job making stuff.
You do engineering videos, and there's also content there about your time in China, right?
Yeah, absolutely.
How do I say thank you in Chinese? How do I say thank you?
谢谢.
So that gives you a peek into the world of Chinese manufacturing, but on the American side, it's very different. We talked about this when I was a guest on a podcast called Search Engine. Shruti and PJ invited me on to talk about what it was like to try to find a mold maker to make this thing.
This was a light bulb moment for me in the conversation. The problem is not just that we've forgotten a lot about how to make things in America, it's that we're also forgetting how to make the things that make the things.
We go deep into the topic of the tool and die trades in America. It's fascinating. Check that out. I called Chris Robeson, the guy that made the mold during the pandemic, and I asked for help. And not only did he agree to help me, he decided to mentor me. The first thing I did is send him my CAD files.
Quick note, that text on that model, wildly going to increase the cost of the mold. Not wildly, but increase the cost of the mold.
Of the drawings, and he told me everything that was wrong about them. I had to redesign things because there were things I didn't understand about injection molding. For example, you don't want some areas to be too thick, you want draft angles, all these things. Chris walked me through the process and taught me the proper way to design an object for injection molding.
The amount of detail about how to design a part correctly for molding is absurd. Right now, I run a 3D printing company, so we're constantly fighting with people about how to design appropriately for 3D printing. And it's very difficult because, again, a lot of nuance, a lot of rules. So like with molding, you don't want anything thick because if you have a thick piece of plastic, it shrinks and you get shrink lines on the part. Whereas with 3D printing, it's the exact opposite, where you want stuff thick in order to give it cooling space and structure.
There were 3 parts to my prototype, so Chris designed 3 molds, and we wanted to try a new technique. So this isn't a thing that you can do for thousands of parts, but for a few dozen parts, you can 3D print the mold cavities with Formlab's rigid 10K solution. So that's what we did, and these are those parts right here. These are 3D printed inserts that we could run in Chris's injection molding machines to verify that the geometry is correct. It actually worked. We got a few dozen working parts, and this let us see how the plastic would flow in the mold, and we made mold design changes. So it's Chris's vast knowledge of tool making and injection molding that allowed us to create molds that would work. It's now time to make the production tool out of metal. You can send this off and get it done in a machine shop. They're not going to have the knowledge of the tool and die making, but they can just make a metal part if you send them a CAD file. I wanted to learn how to CNC machine. I've always wanted to learn how to do that. So me and a younger engineer named Trent, we started learning how to machine. I was able to pick up 2 used CNC machines. Thank you again, patrons. It started off pretty rough.
Wow! He's running it too fast. Running it too fast. Tore through everything.
Then we figured it out. This process was incredibly enjoyable. I thought it would be intimidating, but I called friends like Shane from Stuff Made Here and local machinists and Chris himself. They taught me what speeds and feeds I needed to use, and this process was awesome. One night I was machining in the garage and my friend Dalen came over to hang out, and we started talking about the importance of making things in America and how it affects local communities.
And all the opportunities to have education and so on went away. And so what's happening?
I'm filming you talk about manufacturing in America.
Okay. Yeah, so when those jobs went away in those communities, all those economic prospects and ultimately educational prospects and quality of life prospects went away. So manufacturing coming back to America is really important to me because of what it's meant historically for communities in terms of opportunities for kids, right? So figuring out a way to do that is something that I spend a lot of time thinking about.
This is an important point. Again, in the context of like, we'll let this ad run on by. In the context of how this affects communities. Right now, for the last like 20 years, there's been an exceptional focus on STEM. And STEM is just translation to like computer coding and programming. And then also there's social sciences and that kind of thing. But STEM, purely on coding, a lot of kids aren't wired to do coding or like purely mathematics and that kind of stuff. And there was like this bad presumption that everybody could learn it, and it's not. Some people are very tactile because, quite frankly, we're humans. I am a very tactile person. I learned more about engineering in woodshop than I did from my engineering classes. So it is terribly, terribly important to have a diverse job market. So that there are multiple things being trained, multiple things being educated about, so that the different types of people that come through have some place to go that gives them a fulfilled sort of a life. Because a lot of people are not happy writing code all day long, sitting in front of a computer. Some of them want to go build things, but they can't know that and discover that if there aren't things available to be built and the training and infrastructure to help them get to that. Right now, this happens. Mike Rowe pushes on this a lot about like bringing trades back into schools so that kids can beat a nail with a hammer and that kind of stuff, which creates a much more rounded human and a more useful and diverse and functional job market.
That there's a couple of things that weren't quite right. They then took the time to fix it, and then they put them all together. And this is what was interesting to me. I realized that a machinist is not enough to be an injection mold designer and maker. They're two different things.
This is, again, in my context, someone with a 3D printer is not qualified to design 3D prints. The nuance and the engineering that goes into making this kind of stuff is more than functionally how the tools work. Like a machinist can make a mold, but they can't necessarily design the mold because there's just additional knowledge and expertise that's necessary.
You have one set of skills that feeds into the other, but ultimately that tool and die creation is its own thing. But here we are, we have these beautiful molds and we're ready to make parts. It felt so good to watch parts pop out of these injection molding machines, knowing how much work went into the molds. It was awesome. Out of the 3 injection molded parts, it was the squishy part that I was most concerned about. Now, this is made out of a thermoplastic polyurethane called Santoprene, and it's only
For the 3D
heat
printing
resistant.
people out there, that's TPU.
Up to a few hundred degrees Fahrenheit. John did a test.
Yeah, definitely got some melt in there.
So obviously we were gonna have to change that material, and silicone is the best option. Now the problem is we can't inject silicone with the same molds that we made. It's a whole different process. Unfortunately, I couldn't find anybody in my area. They just weren't here. So I had to reach out to a guy in Virginia called Commonwealth Manufacturing. Kevin hooked us up. He made a 9-cavity mold so the silicone process could work. So by switching from the Santoprene to the food grade silicone, we bought ourselves another couple hundred degrees Fahrenheit. However, it's not meant to be used on a fiery furnace, blazing hot grill. It's meant to be used on a cold to warm grill. The handle has its own story, and there was a ton that went into this. The first thing I did is I found a metal tool that I liked, and I just went over to an anvil and I just beat a little flat edge on the end of the thing, and then I cut out the end on a bandsaw and drilled a hole in it, and we put that on the prototype and gave it to John's mom to test.
This is great.
Since it passed that.
By the way, that's a fantastic way of testing a product. To go to the extreme. In our factory, we're like, can a 13-year-old girl do this? Perfect. Then it is ready for everybody else. Otherwise, it's too hard for people, or it wears folks out and that kind of stuff. You cannot design for yourself as the designer. You have to design for the extreme case of who would be using this. Make it work well for them, and then go from there.
That test, it was time to design it for manufacturability. So I went back to CAD and realized if I was going to be bending up sheet metal, I might as well put a flat scraper on the front so that you could get into the corners and stuff like that.
Hold on.
I put a little bitty curve on the edge of the scraper so that you could get around the grill grates, and that was our design.
I fully understand why that. Oh, goodness. I understand why all this stuff is there. Destin radically increased the cost of the tooling for this part. Also increased the cost of the part. That side flange, this thing is going to start from a solid sheet, right? So you have a solid sheet of steel. It has to be as wide as that front flange, depending on how they made it. Maybe they welded that thing on the end ultimately. But if they are doing this purely stamped, you have a flat sheet, and then it basically cuts out a T shape and the handle flange up on top. It's imagine cutting that out of a sheet of paper and then rolling it into that shape. It's an origami project, is what stamping is. He is making a piece of sheet steel this wide that is as wide as that front tongue. If I was redesigning this, and maybe they did this, that front tongue should not be wider than the uncurled handle at the back. And they might have done that. But even then, like, the handle It would be simpler if this was a single strip that they bent a little bit to give some stiffness and then bent the end of it all to hold it up, and then put a fat handle on the back that was like injection molded. That would be cheaper. It has an assembly step, but you use some glue and it's quick and easy. Destin, you're fantastic. This is a little bit over engineered. The flat in the handle also just added another stamping step. That really expensive in tooling.
I made a video on Smarter Every Day about sheet metal stamping, and the reason is because I was doing research into how to manufacture this handle. Sheet metal stamping is a process that involves using tooling to cut and bend metal into the shape you want. When we made that video at TNC Stamping, I spoke to a tool and die expert named Roger, who taught me some critical concepts about tool and die. It was pretty clear to me that Roger had forgotten more about tool and die than most people will ever know. In the time between filming that video about metal stamping and filming this video, Roger passed on. He's no longer with us. And that's a big deal. Obviously, his family and friends and coworkers are going to miss him. Roger seemed like a great guy.
Probably takes years just to learn the vocabulary of the trade, right?
You hear that? It takes years to learn to speak like I speak.
But there's another loss here for the community that's not as obvious, but it's very important. And that's all of the experience and tool and die wisdom that Roger has acquired over the years. He can no longer pass that along. We only have what he gave us while he was here.
This is one reason why I'm doing this video. I think this video is too long and is bad content from that standpoint. But hopefully I can add just a few more nuggets to what Destin is doing so that whatever experience he and I have collectively can at least live on the internet and can train some AI so that hopefully whatever we have as young dudes, super young dudes with no experience at all compared to the rest of the fellas here in this video, can at least build up a little bit so that an even younger person can come on up and find some resources to get started.
All the experience of the person that taught Roger, all that has stopped now. All we have is what he passed on before he left. So that makes what you are about to see very, very important. You're about to witness the birth of a tool and die worker in America. When I first visited TNC Stamping, Weston explained that they had a tool and die shop and they invest heavily in their tool and die apprenticeship program, which is becoming increasingly rare among American manufacturers. They showed us
that cannot be overstated. American manufacturers are terrible at training. Right now, we have inside of our local community, we have a community college that does machining and welding and that kind of thing. And everybody sources from that community college. And I talked to the local business owners who are doing this kind of stuff, and they're all like, yeah, the people who are output from there are not good enough. And I'm like, great, well, why don't you guys set up your own school? And they're like, because CWI is supposed to do it. And I'm like, what are you talking about? This is your employment pipeline. If you don't have a welder, you can't do more work and grow. So why are you not very explicitly investing in training of these people? And not just giving advice on what the program should do and giving the feedback of like, oh, well, you should train them better, which is ultimately what that feedback is. So the poor administrators of these schools can't help. But American manufacturing has the margins, has the money available to create schools that are very focused to a particular form of manufacturing. A local example I use is a trailer company that makes a bunch of trailers and lowboy trailers and that kind of thing. And they can't get welders. And I'm like, literally, you guys have 1,000 square feet over on that side of the shop. Let 2 kids come in and pay you tuition to learn how to weld. And then one of your old welders who's retired, pay him half salary to come in and watch them and make sure they don't cut off their fingers and give them the expertise that he knows. Just create a little welding dojo over there on the side. It's not expensive. They don't hurt anything. They wouldn't consume anything other than materials. And if they're good, you have a welder and they have a job. And it's stupidly useful as compared to a college where employment is not guaranteed. The training is indeterminate as to whether it's good or not until after a full batch, as opposed to on the day-to-day. American manufacturers are terrible at training people. We've talked about this at Slant 3D. We've considered a foregone conclusion that as we grow, we will have to create a school of some sort. The YouTube channels that we do are like the first kind of iteration of that. But like we have to train people in our processes and how to do stuff because it's just not being trained.
It's the progressive stamping dies that they made, but John and I couldn't afford one of those, so Weston agreed to give us a price to make what's called station tooling. A tooling engineer named Joey worked with a young man named Logan. Logan used to be a press operator, but he's entered into the apprenticeship program for tool and die. The tool that made our handle is the first tool that Logan ever made.
This is the first one you've made?
Yes, sir.
And how long did it take you?
About 6 weeks.
So are you been training him?
I've helped. He's a lot of help.
So do you feel like you know how to do the next one now?
As long as I got prints to go by, I can build it. Yes, sir.
Really? Did you ever think you would have this skill?
I never knew anything like this really existed. During high school and everything, I didn't know what I was going to do. I started out up here as just a press operator, actually running these presses, and got the opportunity to move over as an apprentice, and I've enjoyed it ever since. All the hands-on stuff, learning stuff every day. I've really enjoyed it ever since I've been over there.
It is really fun to watch the tool Logan made in action. Flat blanks that are...
Okay, so they did make it the appropriate width. The blank is no wider because of that T-slot at the front. So they did make the adjustment there.
Cut out with a laser are loaded onto the tool where, as the press comes down, it gets bent into a specific shape. Laser are loaded onto the tool where, as the press comes down, it gets bent.
So
that have been cut out.
Does the one on the right does the impression. The next one does the curl, and then the next one does the primary bends, or some finishing bends.
With a laser are loaded onto the tool where, as the press comes down, it gets bent into a specific shape along the way. It's called station tooling because the part is then moved from one station to the other, and progressively the different bends and shapes are put into the part.
So look what happened there. There's 3 steps in it of like main bend, secondary bend, and then final curl. A person has to move those 3 parts down each time. That's really slow. Like that cycle time right there was probably about 5 seconds or so. So you get, what is that, about 10 a minute? So you can get, excuse me, about 600 an hour, maybe, if a person's really cranking along and all the rest of it. But actually, that wasn't a 5-second cycle time. That was about a 10-second cycle time because I didn't see all 3 of them move through. But that's what's so slow versus the automated version where it run through all the steps, and that progressive die would knock one of these things out every second or so. With a single motion, a whole one would come out. Whereas with the single motion, you got to move through everything, and then you do the single motion, move through everything, single motion. And that's the difference that automation makes.
Side action that bends the handle around into a tube is my favorite. After that, we put them in a box and we take them back to Chris's place where we lays a logo on the handle.
I appreciate that you guys are making a high quality product that lasered on there, but consider a sticker. Consider a high quality heat resistant sticker. Please, Destin, please do it for me. It'll save you so much time.
Which is really cool. This is currently the bottleneck in the process. It's a little slow. We're trying to automate this. But my favorite part, we get to put Made in the USA on the handle. How cool. All of the
I understand why they don't want the sticker. It's going to peel off. People are going to wear it off and that kind of stuff. This is a reason for like the injection molded handle, because the injection molded handle can have that information embedded in it so that you don't have to laze it onto the steel. And then you remove one stage of the stamping process. They could have removed 1/3 of their stamping process if the handle had not been a rounded piece of steel. And instead, just a blank that you put an injection molded plastic part onto. It's still heat resistant and will hold up well. Also gives it some color, so it's on the shelf. People can see it. And it never has any like danger of rusting or anything like that, but that's not a problem with this steel.
These parts down here go together to make the scrubber head, and the scrubber head is put together with a piece of stainless steel wire, which we have confirmed is made in Pennsylvania. Now the rope, however, is harder to confirm the
To assemble this, someone has to thread that needle of wire through all the outer rings and then pull it together. That's hard. That's labor intensive.
Manufacturer's location. We haven't been able to verify it's made in the USA, which brings us to the knob. This is an off-the-shelf item that we ordered, and when we ordered it, we were told it was made in America.
We have a problem, right?
That's right.
So we thought they were made in America, but when they got here, they're not. They're made in Costa Rica.
Costa Rica isn't... Oh, no, not Costa Rica. No, I'm thinking of Puerto Rico. Never mind. Apologies. Costa Rica, yeah, not made in America.
So we've got to fix that. So
yeah,
that's what we get.
So the first 20,000 lucky customers are going to have their scrubbers with Costa Rican knobs.
Yeah. It's probably going to be more than that because it's going to take me a while to figure out how to make a mold for this.
Chris and I are already working on this mold, but we want to reach out to this new company that.
It's a challenge because it's an overmolded part. They have to have that metal piece on the inside. I would make the argument, this is the type of thing that we would make. At Slant 3D, we produce 3D printed parts. That type of a knob is exactly the sort of thing that we would do. And we could put a heat insert into it to where it's still a good, durable, reliable part. But you don't even need a heat insert. You can make a 3D printed version of this and do just a press insert into it that will bite into it really, really well. And 20,000 of those is easy to make, and they would still be very cost effective. They're probably getting those for like 20 or 30 cents, even from Costa Rica. Well, given the cost of all their other stuff, they might be up to 80 or $1 even on those, but I don't know.
Nice to meet you, Ted. How are you doing, man?
Good. How you doing?
So you own Mantle.
That's correct.
So I found your company because the injection molder that I know, Chris Robeson, he's been wanting to like work with your machines for years. My understanding is that you are a 3D printing company that can print metal. Is that right?
That's correct. That's all we do. We had invented a new process to print metal, and we specifically use it to make injection molds and other type of hard tooling like that.
What I've seen with some of the powder bed fusion, laser sintering type methods, is that it's very difficult to get a good surface finish. So how are you doing metal with a surface finish that's acceptable for injection molding?
Yeah, most of the other processes that do metal printing melt metal powders with a laser, and they end up with a surface finish that's like 80 grit sandpaper, and it's just not near smooth enough for injection mold tools. Our process is actually a hybrid process, which means it uses additive plus subtractive. So we actually put down this metal paste, we dry it so it firms up, but then we, after a few layers of that, we come in and actually cut it with a CNC. So we get a CNC-like finish out of this material. And then as a secondary step, we put them in a furnace and densify the metal into a solid metal part. But we can do things you could never do traditionally, like in, this medical tool right here looks pretty simple, but these deep grooves you see here have to be done with electric discharge machining. You can't CNC cut those because no one makes an end mill that's skinny enough and long enough that won't break when cutting steel. Our technology allows us to sort of shape, refine, or cut that material as we build up the part. And so we get a part that can get any of those really unique geometries you need for tools.
So your technology is aimed at improving.
So they're able to make molds that are deeper than anything else because machining is really, really limited as how deep it can go. But they can also just do geometries that are way more difficult. And they get the surface finish because they actually polish the part layer by layer as they're growing the part layer by layer. So it's a really good system.
The tool and die industry. What are your thoughts on tool and die makers in general in the US?
I think we need more of them. I think the incentives to go into tool and die have gone downhill. So I saw a New York Times article that showed a graph that in the 80s, 90s, tool and die makers were above the average by about 20% in terms of income in the United States. That's dropped today to 15% below the standard income.
It's important to say that like these are the averages across all the stuff. But yes, machinists and that kind of stuff definitely have lower wages. A machinist in like the state of Idaho and stuff, a machinist can be hired for about 20 to 25 bucks an hour, which is fairly low for the value of what it is that they can create. But it's just, yeah, it's still more expensive to machine the part in the States than overseas. My argument for why machining is that way is really around process control. The machinists over in China are busy. The machinists over in America are not. And so many of them are either in a factory to where it's low value machining, or they're independent and small business operators to where they're just really inefficient because they're small business operators. No one has recombined scale with machining really reliably.
Income level. And so it's tough to justify going into tool and die.
I think that's changing. I've noticed that people really like making things in America. I'm excited about it, and other people I talk to are excited about it. And your technologies like yours are very interesting.
Destin's correct about this, but to put a little bit of water on the fire, people are really excited to make in America, consumers are not excited to buy in America. It literally, especially right now where there's kind of economic stress, it's really tough for people to justify the cost of buying an American-made product. Manufacturers want to do it. They're totally fine with doing it, but they have to make sure the thing sells. And it's so expensive and there's not enough brand loyalty to made in America that people will do it. In our own case, like filament, we made filament for $10 a spool, made in America. It sells really well, but that's because it's the same cost or less than exterior options, international options. And we did that purely through automation and simplification. But we're happy to make in America, but like if we had been more expensive, the business never would have worked.
Demand for this, right? So I talk to companies every day. They're like, I've got tool and die makers, but they're about to retire. They have open jobs today. There are tons of positions available. So I think that it's looking up for tool and die, especially when you combine it with new technology.
I think the time to get into a thing is not when everybody else is doing it. It's before the wave happens. So if I was a young person, I would be looking into this right now.
They're not wrong, because as many people retire, the wages are going to start going up. So that if you are a tool and die engineer, everybody's retired, there's no one available, your salary is going to be more valuable.
Just say that AI is taking software coding jobs left and right, but it's not taking tool and die jobs.
Interesting. Yeah. Mechanical, physical things are where it's at, isn't it?
We're not there yet. The Optimus robot can barely serve a drink, at a party for Elon Musk. It's not going to make a tool and die anytime soon.
That's a great point, Ted. I hadn't thought about that. So the reason I wanted to reach out to you is I'm trying to make this product in America, and we're doing everything we can to make everything in America. And my understanding is we were told that this right here was made in America, but when we got it, the box said made in Costa Rica. And so obviously I have to make it in America. And so I've learned the hard way. I'm not saying the hard way, but I've learned the right way, or the traditional way to make a mold insert. And I was wondering if you'd be willing to work with me to make another mold using your technology for this knob.
That'd be great. We print stuff like that all the time. We can do all types of geometries. That would be a shoe-in for our technology, and we could do it a lot faster than you would normally as well.
Will you?
We can knock them out with direct 3D printing just as well. We're going to have to do a video about that one of these days. If we can do a video about a knob.
Please help me.
I will do my best. I'll do my best. Anything to keep grill brush bristles from ending up in people's throats is definitely something I'm on board with.
That's right. I saw your email on your reply to this. So maybe we could talk about that in the pitch in the last part of this video.
For sure. I've experienced the problem firsthand. It's funny you said in your email, like, yeah, people know someone that knows someone that's had this problem. Like, no, that's me. I've had this problem. I'm the guy.
That's great. We'll talk about that later.
So that's the story of how we made the smarter scrubber, but there's one more thing you need to know about. You remember I told you that we had this American chainmail, and we wanted to get some more chainmail, and we had to go to India to get the quantities we need in the event that we sell out of everything we have from the American chainmail. Well, I'm in the middle of making this video, and a couple of days ago, I thought it would be good to go show you a pallet of the American chainmail and a pallet of the Indian chainmail to show you that they're two separate things. While I was filming that, something crazy happened, and the camera happened to be rolling.
Okay, so this is chainmail that we haven't used in any assembly yet. This is from India. Dude, look at that. That's not from India. That's Chinese. Is that
Chinese?
Well,
I didn't even notice that. That's name. He's Indian.
I bet they're just shipping it from China to India. I bet that's what they're doing.
They might not even be doing that. They may be shipping from China straight to you, or have a warehouse in the States, whatever else it was. And the Indian guy is just reselling it.
Is that Chinese?
That looks like Chinese.
Get Google Translate out. We got this drop shipped from India, but I think he just boomeranged it.
I do too.
I think a person in India told us it was from India, but it was actually from China, is what I'm thinking.
It's got Chinese writing on it.
Pu Chuhan Hai Pai. Man, that looks Chinese. What is that?
It says Hai Pai refers to East meets West culture from Shanghai in the 20th and 21st centuries. It's part of the culture of Shanghai.
That's what it is.
Hai Pai. Well, I don't know what that means. But it's definitely not English.
Okay. This is so hard.
It is really hard. It's stupidly hard to build something and manufacture it. And Destin's device is like reasonably simple. He's not building a car or something like that. It's really hard to make stuff. And with the added challenge of doing it in the States and that kind of stuff, yeah, just tracking it around, really rough.
It's the supply chains.
Jack.
It always goes back to China.
Yeah.
And everybody wants to make a dime, so that it's worth it to. I'm shocked.
It's pretty weird to set out to try to make a thing completely in America and to find out towards the end of the process that you made something in China anyways. That's really hard to swallow. So this is a big, big problem. And I have like 100 things I want to say because I've learned so much in this process. And I did a lot of things wrong, obviously. We did a lot of things wrong. But I'll limit myself to saying this one thing. If you are ever in a position to make a decision about where your thing is manufactured, take a second and consider making a little less profit maybe in order to invest in your local community. Because these are people you know and love, and they need jobs, and they need to be able to feed their families. And you need a person in your hometown that can injection mold. You need to be able to do that locally. So that's what I would say. I feel a lot of things right now. I'm not gonna say all of them. It's time for the pitch.
I'm gonna stop it right there. Destin has the scrubber. It's over there. Go ahead and get a hold of it. This was a really good video because it shows how hard it is to make stuff in the U.S. and how hard it is to make stuff in general. Like the 4 years and the number of steps he had to go through to get this made. Each one of the components had its own journey. There are things that Destin could do and can continue to do to improve it and reduce the cost and improve the quality and so on and so forth. It's the first draft, and that's fine. The thing I would say about it, about taking a little less profit, very often that is feasible. Destin is in a particular situation to where he has effectively zero marketing costs in order to get these things sold. Because he has a YouTube channel that he's built up over 10, 15 years that now he's able to leverage to promote it. That's not the advantage to every small business. And while everybody likes to point to the big giant companies for moving stuff overseas, the small businesses do it too because they have to. The cost constraint is even greater on them. So larger companies operate more efficiently, so they have to go cheap. Small businesses have to operate even more efficiently, so they have to go cheap. What is the solution? From my perspective, as a manufacturer inside of the United States, there is a necessity to leapfrog from all the stuff before. So the reason I got into 3D printing is because I saw it as one of the technologies that allow us to not have to rebuild tool and die, but instead move to the next process that has additional advantages on it, and then use that as the fresh beachhead. Because it took a generation to lose like the tool and die expertise, and it will take a generation to regain it, maybe more. Because again, that last generation had all the generations before it to train them. And now there's this gap and people starting from fresh. It's like your grandparents telling you how to saddle a horse. They're not going to because they're not available and there's no horse saddlers in between. So it's really, really hard to restart that engine once it dies. However, if you are able to be on a growth trend of a technology, on a means, a way of doing stuff, then you can continue on and recreate those jobs. At Slant 3D, we do mass production of 3D printed pieces and print on demand. There's business models in there that create all kinds of new jobs, and I'm really proud that the team is able to be paid an appropriate amount. Full stack, because we created something of really high value. And again, if you're creating a product, the easiest way to not compete with cheap knockoff products is to just make a product that is very, very, very good. Make it so astoundingly good that the price you charge is perfectly reasonable. That it's so valuable that people will pay whatever you need to charge for it. And then it is easier to build in America. Create something really good, but then also get on a new technology wave. Create something really, really good. And then finally, remember that you're building a business, and a business is not just the product. It is everything around it. The accounting, the marketing, the distribution, the shipping. All of those are things that contribute to the price. And if you can be really efficient over there, then you can afford the inefficiencies over in the manufacturing, and you can build something really sustainable. So look at the business as a whole, build an exceptional product, and if you can, leverage the new stuff around. Like right now, again, I'm going to circle back around to AI. If you don't have to pay $5,000 a month or something for an accountant or something, because AI can do it for you, you might want to consider that. Accountants are going to get mad because now we'll lose that expertise, but at least now you can afford the manufacturing cost of it. And there's places to trade that stuff around. But use technology, use automation, make a really good product, and look at your business as a whole. And that is how you can sustain and profitably grow without needing to be altruistic about it. Because the only way that this stuff works is if there does maintain an economic advantage to doing it. Because businesses cannot be charities. They have to be effective. And when they are successful, they create all kinds of good out the side of them all as a side effect of it, from jobs and tax dollars and productive members of society and all the rest of it. Ongoing training, education, expertise storage. But the business has to work and can't have an unsustainable cheat code or an unreplicatable cheat code. I cannot tell some other barbecue manufacturer, hey, go get yourself a YouTuber, because Destin's not available, and some of the other ones are not available or cheap. So that's my 2 cents on it all. Hopefully y'all were able to learn something in addition to what Destin did. It's a really awesome video, and I'm glad he's shining light on this whole thing. But it's a really hard topic. But the ways of getting it done is to blaze ahead into the next thing. Have a great day, everybody.